Hello, Uma. Hello, Uma. Is my voice audible?
Yes, ma'am. It is audible.
Yes, yes.
Yes, ma'am. Good evening, all gathered here. Today is our third day of the faculty development program on a data-driven model, empowering the academician for the data science era. I'm very happy to invite you all for this today's session, and I'm very happy to invite Dr. Vimala ma'am, Professor and Head, Department of Computer Science, Mother Teresa Women's University, Kodaikanal. Welcome you, ma'am.
Yes, yes, please, Uma. Thank you for inviting me.
Yes, ma'am is going to handle today the machine learning fundamentals topic, and the second session will be continued by Dr. Muthasivi, madam. Madam, please, madam, the session is yours.
Yes, thank you, Uma.
Ma'am, just a minute, ma'am. Here we are very happy to introduce madam. For that, I'm very pleased to invite Mrs. Srividya, madam, to introduce our guest. Srividya, ma'am, please.
Okay, ma'am. Very good evening to all, everyone. It's my great pleasure to welcome you all to the AICT ATAL sponsored third day online faculty development program on data driven model empowering academician for the data science era, organized by the Department of Computer Application, NADA Saraswati College of Arts and Science, Autonomous Teni. It's an honor to welcome today's resource person, Dr. S. Vimala ma'am, Associate Professor, Department of Computer Science, Mother Teresa Women University, Kodaikanal, with over 23 years of teaching experience and a remarkable contribution in the field of digital image compression and cloud computing. She has guided numerous research scholars and published many papers in reputed journals. Today, she will be enlightening us with her expertise on the topic machine learning fundamentals. I also extend a warm welcome to Dr. Vimala ma'am,
Sorry for the interruption, ma'am. We are very pleased to invite our Dr. Vimala, ma'am, for this session, ma'am.
Thank you. Okay. Shall I start, Uma?
Yes, ma'am. Yes, ma'am. We can.
Yeah. So I first of all, I extend my sorry to everybody because I made you wait for a long time. And first and foremost, I would like to thank the management, the principal, and Dr. Uma for inviting me as a resource person for this faculty development program on latest trends. So with these few words, I think I can start the session. Is the screen visible for everybody?
Yes, ma'am.
Yeah. See, I'll just put off my video. Yes, Uma?
It is not in the slideshow, ma'am. It is the point screen is viewing.
Yeah, that's what I'm searching for that option. But anyway, can you read what is given there?
Yes, ma'am.
Yes, okay. So with that, I'll just start the session. And due to poor signal, I'll just put off my video.
Okay, ma'am.
Yeah, thank you. Thank you. I'm just going to talk about the machine learning techniques and in detail about two machine learning algorithms, that is the techniques, decision tree and linear regression. So before that, I just would like to say how the computer, the technology has been evolved from the beginning till now. So in the earlier days when computers were invented, we were using computers only at the level of data processing. For example, word processor is the best example for data processing, wherein we, due to huge storage in computers, we were just storing data and we were just retrieving it, taking printouts, that's all. No, we couldn't do any processing over the data what we were storing in the earlier days. So that is what the level of data processing. And then it has been moved on to information processing. something better than data processing, wherein if we store data in one form and we retrieve information in another form. Generally, we say processed data is information. So that is how we define information. The processed data is information. For example, I'll just give a simple example. No, a data. For example, for a student, we give subject marks. That is the raw data that is generated in the real world, and we give it to the system. Say, for example, in 3 subjects, she might have scored 70, 70, 70. This is the data we give. We store it in the system. And with the help of database management system, which is an information processing tool, we have Oracle, we have a lot of other DBMS tools. So with these database management system tools, we process the data to bring out information like the subject marks are given as input, it is processed to give output average, and we just find out the result whether he is passed or failed. This is what information. Whereas the information will never change. For example, if we ask even hundreds of people, if I ask which is the capital of Tamil Nadu, everybody will say Chennai is the capital of Tamil Nadu. There won't be change in this statement. This is called information. Information remains the same across people. Whereas knowledge is something more than information. So from DBMS, from the level of information processing, we moved on to the next level called knowledge processing. So we store data in one form. From the huge amount of data, we extract a few information that is called the knowledge. That is what knowledge processing. So from DBMS, we moved on to data mining. Wherein we were developing cognitive systems. We were integrating cognitive systems as part of the database. We integrate both the database as well as the cognitive system. It's nothing but the algorithm which will analyze the data, and it gives knowledge. So for knowledge, I can give a simple example. When I ask few people, who is the best actor, that won't be a same statement coming from everybody. One may say this actor is good, the other may say this actor is good. It is all because of their knowledge level. They analyze the movies, and depending on their intellectual level, they will come out with different knowledge. So that is the difference between information and knowledge. To say it in simple terms, information remains the same, whereas the knowledge differs from person to person. It depends on the intellectual level of the individual people to give knowledge. Knowledge is nothing but some insights after analyzing huge amount of data. And from data mining, we are moving on to the concept. Nowadays, the trend is artificial intelligence. So with the invent of internet, we are pooled with large amount of data and processing the entire data, analyzing it, and finally extracting some insights from the data. That is called a knowledge. And in artificial intelligence, we do the same thing. So artificial intelligence, everybody knows in today's world, even a common man uses the term artificial intelligence. It penetrates into the life of every common man today. So in terms of mobile phones, in terms of computers, everybody is using artificial intelligence. It's an area where computer science that emphasize the intelligent machines that work and react like human beings. One sec, please. Yeah. Creation of intelligent machines that work and react like humans. So in earlier days, computers were used in information processing, but now we are making computers to think like human beings. We are importing intelligence to the computers, and that is again called artificial intelligence. It is not that only computer science aspects are there in artificial intelligence. It is interdisciplinary, wherein we go with statistics, computer science, business trends, everything are put together into a single package wherein we apply artificial intelligence to apply it in all places. Some of the subdomains of it is a huge area, artificial intelligence. Under the umbrella of artificial intelligence, we have various disciplines, various aspects coming under that. One is computer vision. So in computer vision is nothing but the digital image processing, whatever See, in digital image processing, while processing the image, if I give the image as input, and if the system gives the same image as output, that is just digital image processing. Whereas computer vision is something different, where if I give the image as input, the system analyzes the data that is extracted from the images, and it gives some descriptive kind of data out of the processing. That is what computer vision. Computer will get some insights from the data that is being analyzed. And yes, obviously, if we want to apply artificial intelligence in real world, everybody should be familiar with the business domains. So unless and otherwise we have domain knowledge, definitely we cannot come out with an efficient artificial intelligence system. So business is one other part of artificial intelligence. Then speech recognition. Today, when we take our mobile and say, call Amma, automatically it searches for a word named the Amma, and the call is directed to that person. No, if you have a friend with the name X, and if you say call X, automatically call is sent to that person. So that is out of speech recognition. And decision support system, we all know the data that is processed in business, that is called the decision support system, wherein the key persons are involved there who do decision making, which leads to efficient management of business. So that is what decision support system. And robotics, we know robotics nowadays, it is used everywhere, even in household works, in playing games. Robotics are becoming assistants for human beings nowadays. So that is robotics. And expert systems, in earlier days when we were doing UG, PG and all, no, we had a term called expert system. We even learned artificial intelligence there, but the volume of data at that time was less because we didn't have the concept of internet. The volume of data what we have been processing is less. So there we had the concept of expert system. Wherein we call it rule-based systems. All rules is set of numerous conditions, and whatever data we give, the system compares. The system processes the data against all the conditions, and finally it helps us in deciding something. So that is what we call as expert systems. So database management, to say it in simple words, database management system plus data mining, we can call it expert system. Then now machine learning, it is again a major subdomain of artificial intelligence. To incorporate to incorporate the concept of artificial intelligence in any of the software systems, we use machine learning algorithms, and that is what we are going to see in detail today. And knowledge representation. So data representation we do in terms of database. Like in DBMS, we represent the data in tables. But this knowledge representation, we store data in various forms, NoSQL, SQL form, even the Word documents, the graphs, everything is knowledge. And by using machine learning algorithms, so the raw data that is processed and analyzed, it gives knowledge as output. That is in turn stored for future reference in order to go for higher end processing. That is what knowledge representation. And neuroscience and cognitive system, everybody might have heard of neural networks. So that is the concept which is used in deep learning. So neural networks we use, and speech recognition. So it's already there, sorry. And these are all the various subdomains that come under artificial intelligence. So what is artificial intelligence? It is just imitating the human brain. See, when we think of the brain power, it is something amazing, no? Right from the childhood, whatever the child observes that is happening around it, those information are getting stored voluntarily in the brain of the child. And later on, if you go and ask the child, who is your mother, who is your father, or if you show a fan and ask the child, it automatically says it is a fan. When we show a tree and ask the child, it will say automatically it is tree, because the brain has that power and it observes all the happenings, all objects around it. And from every object, from every happening, it extracts some information. And that we call it feature set nowadays in artificial intelligence. Feature set. Say, for example, if it is a tree, the brain automatically detects the information like the tree will be green in color, it has got branches, it has got stem. So these kind of information. So this is called feature set. So whatever object the brain observes, these features are automatically extracted from the object, and that is getting stored in the brain. Later on, suppose when we study in schools, we might have met all our friends, and after 10 years, when we see one of our friends, our brain automatically detects and will say so and so. This is all because our brain is trained with all those data. And whenever we look at a person after 10 or 20 years, automatically our brain computes all the features from the new object. These features are compared against the features that are stored in the brain already. And if there is a match, we will be able to say immediately he is so and so. And this is the concept which is underlying artificial intelligence. The inferences, it is nothing but out of the observations the brain does from its surroundings, it extracts, information, and that is called inferences. It extracts some information from the observations, and that information is called inferences. And these inferences are finally processed to give some patterns. So patterns will help us in identifying the object, which object this is exactly. So this kind of identification can be done with the patterns. So machine learning is a subdomain of artificial intelligence. Everywhere we go now, machine learning, machine learning, machine learning. So without this machine learning algorithms, artificial intelligence concept cannot be adopted in systems. And everyone knows Arthur Samuel is the pioneer in the field of artificial intelligence. And data science, it is a booming technology nowadays because we are pooled with data. So above us, wherever we go, no, above us, large amount of data is processed in terms of network, internet. So in data science, we use machine learning algorithms and deep learning algorithms as tools in data science, which cannot be avoided at all. So machine learning, core components. So something we should know about machine learning. It is a multidisciplinary approach we have already seen. In addition to what we have seen in that picture, like computer vision, speech recognition, etc., etc. Nowadays, statistics play a vital role. So yeah, it is a multidisciplinary approach, and we focus on process, and we have a lot of tools and techniques. So that is what we are going to learn. The machine learning algorithms, they are the tools to process the huge amount of data to come out with knowledge and applications and goals. So by applying machine learning algorithms in business or education field, wherever, so we are helped with taking major decisions. That is what informing decisions. With the information what we get out of machine learning systems, we are capable of taking efficient decisions. And machine learning algorithms are used in prediction, in weather forecasting, in predicting, like suppose we invest amount in share market, so we can predict if in on so and so company, if we can invest money, whether we can get profit or loss. That kind of prediction can be done. And if we invest 10 crores in this business today, can we get profit or there will be a loss? So even in disease, so these are all the applications that come under prediction and forecasting. And patent discovery. Patent discovery is nothing but, see, if we want to say, I'm running a business, I just want to know whether the customer is capable of buying the product from us. So the system will generate some patents. In that patent, it will have some information like his income, his credibility, and the frequency of purchasing items. So that important information will be extracted from all his regular purchases. And that important information is stored under a pattern. And by evaluating that patterns, we will be able to say that customer is a credible customer or not. And we can solve a lot of problems with machine learning, and that we'll be seeing it later in the forthcoming slides. So why machine learning? Sorry, screen. Yeah. So today, machine learning, it cannot be avoided. It is used in many different applications, image recognition, so medical image analysis. So the cancer, MRI, CT, computer tomography images, magnetic resonance images. So they are all analyzed with machine learning algorithms, and with which we will be easily able to identify whether the patient is infected with the disease or not. Biometrics used as an efficient attendance tracking system with face recognition and other things. Speech recognition, natural language processing. Like we have personal assistants like Siri for Apple computers and Alexa. Cortana, it was invented by Microsoft, but it was dropped in 2023. But very commonly used assistants, Siri and Alexa, I think everybody is familiar with that, which completely acts as a personal assistant for us. And recommendation system. So when we get into when we want to see a movie nowadays, we just go for seeing the ratings, how people have rated it. And if many of the people have rated it with higher grades, we will be getting the recommendation, this movie is watchable, we can watch this kind of movie. And products rating, like in Amazon and all, if we buy a product, immediately we will be asked to rate it. See, this kind of ratings are given by millions and millions of people, and these information are collected, processed, analyzed, and it helps in recommending the product, whether it suggests the people whether to buy the product or not, which ultimately helps the business people to improvise their business by concentrating on the products with good rating. And fraud detection. So you might have seen my regular place, from there I access my Gmail is, say I am in Kodaikanal. So every day I get into my Gmail from Kodaikanal. Suppose when I go to a distant place and from there, if I log into Gmail, immediately I'll get a message, your Gmail account is accessed by somebody else from Delhi or Chennai. But that might be the same. So myself will be opening in a different place, but I'll be getting a message saying that somebody else is trying to access your Gmail account from Delhi. So that kind of security can be given with the artificial intelligence system. And suppose if somebody else is illegally coming into Gmail also, I can easily identify and prevent my accounts. So that is what fraud detection in bankings, etc. And Tesla has come out with self-driving cars, automated cars. It is something amazing, no? Without the help of any human being, the car drives on its own. On seeing the objects, it will stop. And if there is a deviation in the path, it automatically changes the direction. So these are all possible with machine learning algorithms. And obviously today, Internet of Things. So we have sensors kept around. So sensors collect huge amount of data in terms of CCTV, in terms of capturing weather information. So from all sensors, we collect the data, analyze them. With that, we will be able to say whether there is a possibility of earthquake tomorrow, or that kind of decisions. Cautious measures can be taken. So Internet of Things play a vital role. Underlying the Internet of Things, artificial intelligence is there, and robotics, and still more. So a typical machine learning algorithm to provide recommendation, just now we saw, no, for any machine learning algorithm, it is not possible to get a perfect machine learning model with less amount of data. So data plays a vital role in having an efficient machine learning model. So obviously we need historical data also, without which the machine learning algorithm will not be able to take a decision, will not be able to help us in taking decisions. So historical data is very much essential. It is processed to provide personalized recommendations to users. Netflix, everybody knows. So the movie site. So it gives a lot of recommendations. It gives a list of movies which are highly watched by many people, based on which we will try to watch the movie. And the machine learning approach, how the working principles of any machine learning model. First, we feed the system with huge amount of data, and that data is used for training the ML algorithm. As the brain of the child is getting trained with the observations, now whatever it observes, it extracts information from the surroundings, and that data is getting stored in the brain, and that is called training here. So we need large amount of data, and we feed the system with all those data. That is called the training phase of machine learning algorithm. And later on, if we want to, one patient, suppose, no, like in a big hospital where they deal with thousands of, say, when we take Vellore hospital and all, thousands of patients are visiting that hospital. So you just think of how many patients are coming, how much data is generated there, how much data is processed. All those data are given as input to the system, with which the system is trained. Later on, without even the presence of a doctor, a patient, when he comes in with the testing data like blood hemoglobin or pressure, whatever it is, no, he will be coming with some data, and that is called testing data for that particular patient. If we feed in the system with that data, the system immediately compares that data alone with the existing data that is already stored in the system. That is, we have already trained the machine with all those data, maybe thousands or lakhs of data. That is called, we call it an instance. For one patient, we have some readings, no, that is called one instance. So this historical data contains lot of instances with respect to the older days, the recent days, etc., etc. So we will be having lakhs and lakhs of instances already stored in the machine. When a new patient comes in with some readings, with one instance, immediately the machine learning algorithm compares this instance against the lakhs and lakhs of instances that are already stored in the machine. And if there is a match, it takes that instance there. Along with that instance, they might have stored some data, like that is called a label. So the label will be either the patient is infected with cancer or the patient is not infected with the cancer. That is what the label already affixed to the instances that are already stored. So when a new patient comes in, his instance is compared against the existing instances. And whatever label that is stored against that instance, the system will say, okay, this new patient is affected with so and so disease. So this is what classification. So this is a main function that is carried out with machine learning algorithms. And this is how the machine learning approach is done. So whenever we get any result, we have to evaluate it, first of all, whether the result is correct or not, because we will be having some, suppose one patient is coming in, the system is saying he is infected with cancer. But the doctor might have identified the patient is not affected with cancer. Then we have to evaluate the result, whether it is correct or not. If it is not correct, we have to look into other aspects, like whether the training data is sufficient or the model is generalized, whether the model is optimized. Then we have to go and update the machine learning model in order to give proper results in the future. So key aspects of machine learning, three main phases of machine learning algorithm. See, task. The main task is predicting, recommending, estimations. These are all the main tasks. So experience, it means it is defined as learning. We have to train the machine with historical data. That is what experience. Today, in real world, as far as human beings is concerned, we ask, if he is an experienced person, definitely he will do the work efficiently. It is because of the information what he has gained in the earlier days. So likewise, we have to train the machine with historical data, and that phase is called, that aspect is called experience. And we have to train the model. It is defined as the task to resolve any machine learning task or problem and provide the best outcome for the same. So we have to repeatedly generalize the model in order to give best results. So applications of machine learning, see, it is applied in various fields like automatic language translation, medical diagnosis, stock market trading, online fraud detection. So in various areas, the machine learning algorithms are used nowadays. Still more applications. Yes. In healthcare and medical diagnosis, automatic detection of disease. Just now we saw the concept of neural networks is used. It helps specialists for providing quality treatment by analyzing external data on a patient's condition. For example, X-rays, CT scans, various tests and screenings. Nowadays, we can give personalized treatment for each and every patient. See, many patients come under same disease, but the treatment required for every patient differs from patient to patient because depending on their physical condition, their history, etc., the treatment has to be personalized. So nowadays, AI helps in giving personalized treatment for every patient. It is helpful for clinical decision supports, marketing. Marketing is nothing but the sales promotion. The machine learning helps marketers to create various hypothesis testing, evaluation, and analyze data sets. So before starting the business, the machine learning algorithms process the sample and it identifies whether there is a demand for that particular product. If at all, it identifies that there is a very good demand for the product, it helps the business people to start the business at all. And self-driving cars, we have seen speech recognition, traffic prediction. So in traffic prediction also, artificial intelligence algorithms are used. Product recommendations, we have already seen automatic translation, logistics in transport, route planning and predictive delivery times, which is the optimal route through which if we send the products, how fast the products will reach the destination. So this kind of decisions can also be taken with the artificial intelligence system. So techniques. So we have seen how artificial intelligence is dominating the present world. To bring out such artificial intelligence model, we have a lot of machine learning algorithms to be adapted. So these machine learning algorithms are classified into 4 different kinds, that is supervised, unsupervised, reinforcement, and semi-supervised learning. Supervised algorithms. So these learning techniques, supervised learning techniques, help us to predict future events with the help of past experience and labeled example. So supervised, the instance, as I told, the information about one particular object, maybe a human being or maybe a product or maybe any event. So if we collect the data about a particular object, that is called an instance. So while training the machine along with the instance, we attach label. So label says, suppose for patients, the label says whether the patient is infected with that disease or not. This is called a label. So if at all the data is attached with label, then supervised machine learning algorithms can be applied there. Whereas unsupervised learning algorithm, we don't have, it is unlabeled data. So where we go for using unsupervised learning algorithms. Here a machine is trained with some input samples or labels only while output is not known. The training information is neither classified nor labeled. Hence the machine may not always provide correct output compared to supervised. So we can say supervised learning algorithms are efficient when compared to that of the unsupervised learning algorithms. Then comes the reinforcement learning. So it is a feedback-based machine learning task. So generally we go for deep learning, neural networks. So first we give some sort of input and that input is processed. We get output out of that system. We check whether that output is the expected one. And if it is not the expected one, we send the feedback to the neural network, and again it processes. So for example, for the first day, if we teach a student, this is the input we are giving. Immediately, if we ask the student to write the exam, definitely the result will not be up to the expected level. The next day, we add some weights. We will give some more time for her to learn something, no? And after that, if she writes the exam, maybe she'll be scoring 80. My expectation is 90. So here the error value is 10 because I am expecting 90, but the girl's result is only 80. Then again, I add some weights, no? I give some sort of training, or I give time to learn extra. So the third time when she writes the exam, maybe she will come out with 90. That is the expected output. And if I get the expected output from the model, then I stop training the model, where that model is the optimized model. So this is called reinforcement learning, which works on feedback until we get the expected result from the system. And semi-supervised learning is the combination of both supervised as well as the unsupervised learning. It is an intermediate technique of both supervised and unsupervised learning. It performs actions on data sets having few labels as well as unlabeled data. So after processing the unlabeled data, the unsupervised learning will be able to identify the label, and by attaching this label along with the data, it becomes labeled data which can be used for supervised learning in the future. Feature set. So feature set, it refers to the collection of measurable properties or characteristics called features or attributes used as input variables for machine learning model. See, whenever a patient, if he comes in, so some of the test readings we will be having, no, like HB level, his systolic pressure, body mass index. So for everything, we have some values out of tests. So these values are collected and stored as a feature set. Okay. And if there are 100 patients, we get 100 feature set for 100 different patients. We call this entire feature set as a data set, patient data set, product data set, students data set. For a student, we will be having features like register number, name, subject marks, semester number, etc., etc. This is called a feature set. So likewise, if there are 1,000 students, we'll be having 1,000 feature sets. If we collect them together, that forms the data set. See, we have given some examples for feature set. So for students' performance prediction, obviously, we use machine learning algorithms. To feed the machine learning algorithms, we need the data set. One thing is like the feature set here, age, gender, attendance, study hours per day, previous exam score. So based on analyzing this data, the system will be able to say in the next exam, this student will score maybe 80 or 90 or between 90 to 100. So this kind of prediction will be done by the machine learning algorithms. So I have given three different feature set for three different students. Altogether, it's called a students data set. For car price prediction, so if I want to buy a car, I will be analyzing various information about the cars, the brand, in which year it was manufactured, how many kilometers. Say, suppose if I want to buy a car in second hand, I analyze various details like this, and these details are given as these details together is called a feature set, which is used for training the machine learning models. So example, I have given two instances for two different cars. So one other thing for disease diagnosis for patients with various details, age, BMI, these are all feature set. And the thing that is given at the bottom is called the data set. But here we have only 2 or 3 instances, but that is not sufficient for training any machine learning model. We should have the volume of a high volume of data to train the machine learning models, maybe in lakhs. Only then we will get a proper optimized model which will give accurate prediction. So why faculty should learn machine learning model? See, when we do research, we have a lot of options to do research in machine learning field. And we have seen a lot of applications are also. So we can select any one of the area, and there are already many systems available. Artificial intelligence systems are available. We have to study those systems, and we have to identify the gap, what in future, how it can be extended. So that will be the base work for us. And with that, we can start our research. And to teach AI concepts in an understandable manner, first of all, the teachers should be very clear in understanding the machine learning concepts, and only then we can deliver a quality lecture to the students. And enable data-driven research methodologies, expands collaboration with industry and academia. So nowadays, R&D departments are there in many multinational companies, and if we are very good in machine learning, we can have association with those companies to come out with innovations. So for which we need to learn machine learning. So we have a lot of machine learning algorithms, classification, k-means clustering, many learning algorithms. Of those algorithms, I am just going to touch two algorithms called linear regression and decision tree. So linear regression. Linear regression is one of the simplest and popular machine learning algorithms recommended by the data scientists. It is used for predictive analysis by making predictions for real variables such as experience, salary, cost, etc. So if we want to fix the cost of any product, or if we want to decide whether loan can be given to any person, or maybe after at the end of 10th year, how much he will be earning, this kind of predictions can be done with linear regression. So the fields where linear regression is applied are weather prediction, investment. In share market, if we want to invest, first of all, we should identify a reputed company. Only then we can invest on shares over that company, which will give profit for us. So to identify which is a reputed company, which will give more profit, then we can rely on machine learning systems where linear regression algorithms play a vital role there. And it is a statistical approach where we use many statistical computations to arrive at the solutions that represents the linear relationship between two or more variables, either dependent or independent, hence called linear. Linear. If there is increase in independent variable, obviously the dependent variable will also increase in its value. So that is what we say linear regression. If there is a decrease in independent variable, automatically the value that will come out of the dependent variable will also decrease. So this is called the linear relation between these variables. Linear regression is helpful for evaluating the business trends and forecasts, such as prediction of salary of a person based on their experience, prediction of crop production. So if this is the weather condition that is prevailing now, then what seed we can sow, or what kind of vegetation we can go for, depending on the weather conditions. So these kind of predictions can also be done with, one second, please. Sorry. Then decision tree. This is one. This is another simplest machine learning algorithms, which is used in large scale to bring out artificial intelligence concept. It comes under supervised learning. It is similar to K nearest neighbor. The decision tree also helps us to solve classification as well as regression problems. Classification, whatever data we give, the system will be able to say for example, again, the patient detail. If we give set of data, the system will say whether he is infected with the disease or not. So the decision tree helps us to solve, this is called a classification kind of problem. And also it is used in regression problems, but it is mostly preferred to solve classification. Decision tree is for classification problems. The decision tree, it consists of a tree structured classifier in which attributes, we have seen in the previous slides, attributes, the subject marks, the car distance travel, we have seen in the previous slides, no? So these are all the attributes. So the decision tree is a tree structured classifier in which attributes are represented by internal nodes. We know tree consists of many nodes. Decision rules are represented by branches. So depending on the rule, we branch. So branches are there, and the outcome of the model is represented by each leaf of a tree. So the tree has the root node, then branches, and finally leaf nodes. The leaf nodes give the class to which class the instance belongs to. The instance belongs to. So the leaf nodes give the class, whereas the branches, by checking a condition, we will branch into class A or class B. Maybe there are many students. We are going to test them to admit it to higher education institution. So we want to check whether they are eligible to be admitted or not. So based on the attributes, we check some conditions, and based on the conditions, we branch the tree into two directions. One direction will lead to a leaf node stating that she is eligible, and another branch lead to a leaf node stating that the student is not eligible. So this kind of activities can be carried with decision tree. So we will see linear regression in detail. It predicts continuous outcomes. For example, in a business, say maybe in 2020, how much we invested and what was the profit. In 2021, how much we invested, what was the profit. Likewise, we have continuous data, temporal data. By analyzing this temporal data, the linear regression algorithm will help us in predicting if we invest this amount in the business now, what will be the profit we will get, or whether we will get the profit or we will end with loss. So these kind of predictions can be given. So it establishes a relationship between dependent and independent variable. So dependent variable and independent variable, for example, if a student studies for 3 hours, her output will be high. Independent variable is the number of hours put for study. Dependent variable is his result. Result always depends on the number of hours given for study. This is what. So the marks what she is going to get out of the exam, that is dependent variable. The number of hours she is going to put into effort, that is called independent variable. So this kind of relation is analyzed, and depending on the values stored in the independent variable, and by analyzing them, the system will be able to say whether what will be the outcome of the student or what will be the profit or loss in business. So we have a lot of applications. And there are two types of linear regression algorithms. One is simple linear regression and multiple linear regression. If there is only one independent variable, we call it simple linear regression. If there are multiple independent variables, we call it multiple linear regression. In farming, we consider many weather conditions like temperature, moisture content. We have other things, no? So based on all these attributes, we have to identify the dependent variable. The output will be less or high. So there is one dependent variable and multiple independent variable, that is multiple linear regression. And the previous example I told you, the student is putting 3 hours of study, out of which she is getting, if she is capable of getting 80 marks, another student, if she puts only 1 hour of effort, definitely she'll be getting less than 80 marks. So this marks is dependent variable and the number of hours is independent variable. And there is one other application predicting house price also. So let us see how linear regression works, the working principle. See, this general equation is used for any regression algorithms. Beta naught, beta 1, x plus e. Y is the predicted value. Say, for example, we just want to predict a house price. I want to buy a house in a particular area, and I just want to predict the price of any house with this many bedrooms, this big hall, this kitchen. So if this kind of house is expected, what could be the price? That is what I am going to predict, for which linear regression is very much useful. Linear regression equation. Y is the predicted value. Beta naught, intercept. Intercept is nothing but the basic value which is always added. Expected value of y when x is equal to 0. Say, for example, if x is the number of rooms, in a house with 3 rooms, the cost will be maybe 30 lakhs. If I expect a house with 5 rooms, it will be 30 lakhs plus. So that this X denotes the number of rooms. Whereas this beta naught. So beta 1 is nothing but, for example, for every room, if we uh, increase the value by 5 lakhs, say I want 3 extra rooms. For each room, I have to pay extra 5. It means beta 1 is 5 lakhs, X is 3. So 3 into 5, 15 lakhs. But this beta naught, which is called the intercept value, say I'm just going to buy a house in an area of 2,500 square feet. So that cost is same for every person. No, the area of the cost of the area, the land is 2,500 square feet, and its value is maybe 30 lakhs. This 30 lakhs is the ground value, to which we add beta 1x. That is, depending on the number of rooms, the amount will be increasing. No, we add that value. So the for land 20 lakhs plus I'm going to get a house with 3 rooms. For each room, say just 5 lakhs. So this 20 plus 15 lakhs, altogether it come around 35 lakhs. So this y is 35 lakhs. What is that epsilon? That is error term. Say when I apply artificial intelligence algorithm, when I feed the system with testing data, it gives some output. Sometimes we might have already tested manually and we get the result in hands. To check whether the artificial intelligence model is working perfectly, we compare the actual result, what we obtain, the expected result, and the actual result, what we get out of the artificial intelligence model. If both are matching, the error term will be 0. And if there is a difference, say for example, the expected value is one thing, and the actual value what I get out of the system is something, there is a vast difference. Then I say the model is not right. Then I have to train the system with few more data till I get the less error value. That's what error term. See here, I was explaining this. Y is the predicted value, beta naught is the intercept value, and beta 1 is the, as I told you, for every room, how much it would be. Likewise, here we have taken an example. After 10 years, what will be the total salary of this particular employee? So the starting salary is 20,000. That is what? Beta naught. See, there is an example. Y is equal to 20,000 plus 10,000 into X. This 20,000 is the basic salary at the beginning stage. And for every year, he gets 10,000 as increment. So that is the beta 1 value. And this X is the slope. That is the increment at the end of every year. See here, at the end of 4th year, what will be the salary of that particular employee? 20,000 plus 10,000 into 4. 4 is X and 10,000 is beta 1 and 20,000 is beta naught, where the Y value is 60,000. So this is the expected value. The actual value obtained by the system is also 60,000, means the model is perfect. Suppose there is a deviation, then we have to retrain the model with other data. And nowadays, visualization is again a major part of any artificial intelligence system because we deal with large amount of data. And in terms of numeric figures, if we look at the result, definitely it will be a confusing one. Whereas if it is represented in the form of image, it will be easy. That is why there is a saying, an image worth 1,000 words. So for the results obtained with linear regression model, scatter plot is a very suitable tool for representing the data in the graphical form. So type of data the linear regression model always deal with numerical data. So because we have seen some examples in the previous slides also. So it works well with numerical data. Continuous or quantitative. Continuous means quantitative. We have seen scalar and discrete values, no? So that is what here comes under. Continuous, it means the data that will be provided by this model may lie between 20,000 to 30,000. We cannot exactly predict whether it is 25,000 or 23,000. Maybe an interval is produced by the linear regression model. So the profit may be between 20 lakhs to 30 lakhs. So that is what continuous. And quantitative, what exactly the output will be. If you invest 10 crores, definitely you will get 5 crore profit. So that is what quantitative. So that kind of data is processed with linear regression model and are represented using scatter plot. So some of the data that is suitable for scatter plots after processed with linear regression models, height versus weight. So we have x-axis and y-axis. If this is the height, what will be the weight? And study hours versus exam. If she spends 3 hours in studying, what will be the exam score? And if it is the temperature, say for example, in summer, ice cream sales will be more. In winter, it will be less. So that's what the relation between temperature and ice cream here. The temperature is the independent variable and ice cream sales is the dependent variable. And years of experience is salary. Years of experience is independent and salary is dependent on years of experience. So some sample data sets which can be processed with linear regression and represented using scatter plots. So these scatter plots shows they are powerful for identifying patterns, trends, and relationships. And it is always a positive curve. If x increases, obviously y also increases. If x decreases, y also decreases. This is what positive correlation. And negative correlation. When one decreases, the other will increase. For example, speed of a car versus time to reach destination. If there is a higher speed, then we take less time to reach the destination. If the speed is less, some indirect relation is there. And this is one other example for linear regression. And no correlation, no clear relationship between X and Y. For example, shoe size versus intelligence. So there is no connection between intelligence and shoe size. So this kind of data cannot be processed with linear regression models. Only the data which comes into positive correlation and negative correlation can be processed with linear regression models. And evaluation metrics, I told you the error, no, we saw beta naught plus beta 1 into x plus e. So how this error is calculated, no? So summation of, suppose if there are n instances, then yi is the expected value and yi dash is the value obtained with the system. You find the difference between, see, we have many tested values, no? Many instances we might have tested. Suppose we have 100 instances tested. So wherein I ranges from 1 to 100. So for all 100 experiments, we have 100 expected values and 100 actual values obtained. So you find the difference between the corresponding variables, sum it up and take the square root. That gives the error value. And here we fix a threshold. If the error is less than the threshold value, then we can say our model can be implemented in the real world or it has to be refined. If the error value is beyond the threshold value, what we have fixed for the system, then we have to redefine the model. We have to optimize the model by training it with more amount of data. And limitation of linear regression, as we have seen, it deals only with numerical values. Categorical data cannot be processed with linear regression. It's not suitable for non-linear patterns. As we have seen, intelligence is in no way connected with shoe size, no, where it is not suitable for processing that kind of data. And very complex data sets cannot be processed with linear regression, we have still more other machine learning algorithms. Now comes the decision tree. So a decision tree is a visual representation of decision-making process. We have already seen it is represented in the form of a tree. Some of the areas where we can apply decision tree, how likely a person will buy the product. So maybe his earning must be more. So that kind of attributes will help us in identifying whether a person is likely to buy a product or not. The key components of any decision tree is root node, decision nodes, leaf nodes. So decision tree is used for classification types. It is used for predicting categorical outcomes. Categorical outcomes, as I said, the patients, we categorize the patients into two patients who are coming to the hospital into two categories, maybe the patients with diseases and the patients with no diseases. So this is what categorical type of data. So to process that kind of data, we use decision tree. Say maybe grade. Say take for example, the employees are categorized into various grades. A grade employees will be in higher position. B grade a little more less, and C grade will be more in the lower level. So even the grades are called categorical data that can also be processed with the decision tree, which is not possible with the linear regression algorithms. So how decision tree works? Suppose we have 1 lakh customer data and we just want to know which set of customers are likely to buy a product and which set of customers are not likely to buy a product. So we have to split this data into two groups. That is, class A is they are likely to buy the product and class B is they are not likely to buy the product. So which attribute is more suitable for splitting the data we have to identify. Here, the affordability of the customer, maybe the income, no? If he earns more than 2 lakhs per month, maybe if it is a costly item, and we just want to know whether that particular customer is capable of buying that product. So we have thousands or 1 lakhs of instances. Each instance we have to take into consideration. In that instance, we have attributes like his name, his age, his address, his income, his buying frequency. These are all the attributes. But which attribute contributes to decision making? Abdina, the income attribute, it contributes for decision making. Suppose if he is an affordable person, if he earns more than 2 lakhs, 3 lakhs every month, then we can strongly say he will buy that product. No? So this is what we have to split the data set into two classes, class A and class B. The decision tree splits the data into subsets based on feature values. Here the feature values are his income, his frequency of purchase. These are all the features. Feature selection. The algorithm selects the best feature to split the data at each node. Every time we have to select the best feature with which we can split the data into multiple subsets. Based on name, we cannot do it. Based on his address, we cannot do it. But based on his income, frequency of purchase, these are all the features that will contribute to the decision making. So those features can be selected for splitting the data set. And this is repeatedly. First time we split the data into two sets based on his income. Then we have class A, class B. Then inside class B, we have to again test the data instances based on another attribute like frequency of purchase. So though he is an affordable person, he will never purchase items at all. If that is the case, then we can classify that customer as the customer who will not purchase the item at all. So in this way, we can subsequently split the data into further subsets. To select, so as a human being, we can easily say, to identify a customer, reliable customer or a likely customer, the customer who is likely to purchase an item, we use our brain to identify based on his income. But as a machine, how it is done? So we have to identify, we have a lot of features, maybe 20 or 30 features are stored for every customer. Out of these 30 features, we have to identify which feature contributes for decision making. So this is again to be done with the computation of Gini index. This is a value which is computed to identify whether that particular feature contributes for effective decision making. So that value is called Gini index. This is also known as Gini impurity, used to evaluate the quality of a split. So Gini index formula, where we calculate that with 1 minus summation of pi squared. I'll be explaining it in the next slide. How to calculate the Gini index. See, an example is given here. Suppose we have a data set with 10 instances, 6 belonging to class A and 4 belonging to class B. So P underscore A is that is 6 customers are likely to buy the product out of 10 and 4 are not likely to buy the product. So that is denoted by PA and PB, 6 by 10, 0.6, 4 by 10, 0.4. We have to compute this PA and PB. Then you take the powers of both the values, 0.6 power 2 squares of both the values. You sum it up and subtract it from 1. We will get a value called Gini index. And this Gini index says the quality of the data set, what we are going to train the machine learning model with. See, a Gini index of 0 indicates perfect purity. It means all instances belong to the same class. It means our model is not good. We have to train the model with uniform distribution of instances that come under both the classes. It is biased here. Suppose I give an instance that does not come under this class, the result what we get out of this model will not be accurate, will not be correct. So that is why the Gini index must be 0.5. See here, the Gini index of 0.5 indicates random distribution. We have both the classes of data. Only then, when we test the model with one sample data, it checks this data against both class A data as well as class B data. And if there is a match with class B data, the system will say this particular instance come under class B. Then we can say the data, the result that is obtained with model is accurate. So whenever we want to test the data set that has been taken for training the model, first of all, we have to compute the Gini index. And if it comes around 0.5, then we can say this data set is a pure data set, which is very much suitable for training the model. And if the Gini index is close to 1, indicates high impurity, classes are highly mixed. So Gini index in decision trees, evaluate this quality of split. See, as far as feature, see in the previous slide, we just saw how to evaluate the data set that is taken for the study. If the Gini index of the data set is less, if it is 0, then you completely ignore the data set, you go for another data set. So when you do research and all, we have to select data sets that are floated in the internet. We have umpteen number of data sets suitable for one particular application. So while selecting the data set, we must be very careful. So which data set is the best one, so that if I train the artificial intelligence model with that data set, the output that is going to be obtained out of that model will be good. So we have to select a best data set for which this Gini index computation is very much useful. And as far as decision tree is concerned, we have to select best set of features that will support decision making. See here, the feature with lowest Gini index is chosen as the best feature. So whichever is having lowest Gini index, we say we have to split the data with that particular feature. Say, for example, I want to know out of 100 people who are rich and who are poor. So his address, it is useless. His name, it is useless. But the income is very much useful. So to identify this by calculating this Gini index. If I calculate the Gini index for name, it will be a high value. You ignore it. If you calculate the Gini index for his address, again you will get a higher value. You ignore that feature. But if you calculate the Gini index for income, it contributes more to the decision making, where we get the Gini index, which is a lesser value. Then we can say income is a best suitable feature which is used for classifying the maybe customers or patients or anything. See, let us take, no, let's say we have a data set with 10 instances and we want to split it based on a feature. Before split, the Gini index is 0.48. See, we calculated 48 for a particular data set. This is for the overall data set, okay? That is 0.58. And after splitting, we have maybe 10 instances are there, no? We have to classify these instances, whether they come under class A or class B. So the child node 1, it shows, no, after splitting 4 instances, out of 4, see, we have split class A or 6 instances at the top. 4 instances and class B 6 எடுத்தாச்சு. இந்த 4 instancesல இன்னொரு ஃபீச்சரை பேஸ் பண்ணி அதை நம்ம ரெண்டா பிரிக்கிறோம். அப்படி பிரிக்கும் போது அதுல 3 வந்து கிளாஸ் ஏ காமிக்குது, 1 வந்து கிளாஸ் பி காமிக்குது. இப்போ ஒரு எக்ஸாம்பிள் கூட சொன்னேன். நம்ம இன்கம் பேஸ் பண்ணி we have split up the instances into class A and class B. இப்ப கிளாஸ் B ல நம்ம என்ன பண்றோம் அப்படின்னா, they are likely to buy, that is the leaf node, no, அதுக்குள்ள வந்துருது. Though they earn more, they don't have the practice of purchase at all. அப்ப அடுத்து நான் அந்த கிளாஸ் பிக்குள்ள போய் இன்னும் அதை பிரிக்கணும் இன்ஸ்டன்சஸ். அப்ப எந்த ஃபீச்சரை யூஸ் பண்ணலாம் அப்படின்னா பர்ச்சேஸ் ஃப்ரீக்வன்சி. இப்போ நான் இது நம்ம as a human being we can easily say, பட் இதுக்கு நீங்க என்ன பண்ணணும் அப்படின்னா, if you have 20 features in a data set, for every feature set you have to calculate the Gini index, and whichever feature has got less Gini index, we can select the feature for further processing. That's what I'm trying to say with this example. And child node 2, out of 6 instances, 3 comes under class A and 3 come under class B. So where the Gini index is calculated as 0.5. And weighted average Gini index is calculated as 4 by 10 into 0.375. See here, first we identified 4 instances coming under class A. And again, if we split that data, 3 come under class A and 1 comes under class B. So that is why this equation 4 by 10 into 0.375 plus other 6 instances, 6 by 10 into 0.5, where I get the value 0.45. So the decrease in Gini index 0.48, this is with respect to the data set, and 0.45, so it is, the dot is missing there. 0.45 is with respect to one particular feature, maybe the income or purchase frequency, where I get the Gini index as 0.03. This indicates that the feature is somewhat useful for splitting the data. And advantages of using decision tree, it is easy to interpret. They are easy to implement also, simple to understand and implement. And handling non-linear relations. As far as linear regression is concerned, there should be some sort of relationship between dependent variable and independent variable. Only then linear regression models can be used there. So if it is not of that kind, then we can go for decision tree, even if it is non-linear. One example we have seen, shoe and intelligence. If the data is of that kind, then we can go for using decision trees. And versatility. So for any kind of data, decision trees can be easily implemented. It can be used both for classification as well as regression tasks. One real world example I have given here. Suppose a bank wants to automate the loan approval process based on 2 features. One is credit score, the other one is income. As we have seen an example to classify a customer, whether he is a customer who is likely to buy a product or he will not buy a product. Similarly here, when we want to give loan for a particular customer, we have to check the credibility. So based on the past information, no? See here, credit score good, above 650 or bad. If it is below 650, then we categorize that as class B. And if their credit score is greater than 650, we categorize those customers as class B. It means we can give loan for them. But that alone will not be helpful for identifying a customer for giving loan. So we have other features like, suppose if he has already availed loan, whether he returned back all the amount or not. So those kind of features will also be there. So after class, the major classification is done, we should take other features like how far he has paid the loans, whether he has not paid the loans. So this kind of features are also to be repeatedly used here to split up the data into multiple level. And finally, we arrive at a less number of instances of customers, which indicates those are the reliable customers who may be accepted for giving loan. So advantages and limitations, it is easy to interpret and visualize, handles both numerical and categorical data. Example, numerical, their earnings in terms of salary. Categorical data, their grade-wise, employee grade. Captures non-linear relationship. If there is no relation between the variables, also we can go for, what is that? Identifying the results. We can classify the data. Limitations prone to overfitting. Overfitting, you might have heard two problems that are associated with training a model with data. We face two problems. One is overfitting, the other one is underfitting. If it is underfitting, it means sufficient data is not used for training the model. So we should go for training the model with huge amount of data. Only then we will get justifiable result from the machine learning models. Say, for example, in one class, there are 50 students. So I am training the model with top scoring students. Maybe 5 students are there. அவங்க எல்லாமே top scoring student. அவங்க மார்க்கை மட்டும் நான் ஃபீட் பண்ணிட்டு அந்த சிஸ்டம் வச்சு இந்த கிளாஸ் எப்படி what is the performance of this class? Now the class will wrongly predict extraordinary class அப்படின்னு சொல்லுவாங்க. It means it is underfitting because I have not trained the system with the marks of poor students also. So insufficient data is there. And whenever I ask the system, it shows, it will indicate, it will say, this class is extraordinary performing class. So this is one best example for underfitting. Overfitting is we train the system with predefined data sets. Enormous number of data வச்சு நம்ம fit பண்ணிருப்போம். But ஏதாவது ஒரு unexpected situation வரும்போது the system will not be able to give the correct data. For example, one student, by hearting, he is capable of answering all the questions. So he has studied everything from the first page to last page. He has studied everything. He is completely informed. He is trained with all data. But still, if we ask a question in general in a twisted way, the same student will not be able to answer the question. Though she has studied everything from top to bottom, the question has been asked in a different way, in a twisted form. The student will not be able to answer. This is a best example for the problem of overfitting. So in case of abnormal cases occur, say for example, our corona period, generally the business is like this. இந்த கொரோனா வந்தப்ப பாத்தீங்க அப்படின்னா மாடல்ஸ் எல்லாம் இந்த வருஷம் நம்ம இவ்வளவு இன்வெஸ்ட் பண்ணா இவ்வளவு கிராஸ் ப்ராஃபிட் கொடுக்கணும் மாடல் சொல்லியிருக்கோம். ஆனா அன்னைக்கு கொரோனா வந்துருச்சு. நீங்க போட்ட இன்வெஸ்ட்மெண்ட் எல்லாம் லாஸ் தான். அப்ப அதனோட அவுட்புட் என்ன ஆயிடுது அப்படின்னா, அந்த மாடல் கொடுத்த அவுட்புட் நம்ம எக்ஸ்பெக்டட் அவுட்புட்டோட மேட்ச் ஆகல. ஸோ அந்த மாதிரி when you train the model with நிறைய ஹியூஜ் வால்யூம் ஆஃப் டேட்டா வச்சு ட்ரெயின் பண்ணியிருந்தாலும் ரேர் சிச்சுவேஷன்ஸை அதை டீல் பண்ணும்போது it gives wrong data. So we have to consider all aspects and train the model accordingly so that there should not be a problem of overfitting also. So only then the model is an optimal model. And difference between linear regression. So continuous data, even intervals. No, as I told you, like in any business model, if I want to check what would be the profit, it gives an interval like from between 10 lakhs to 25 lakhs. the profit will be between 10 crore to 25 crores abroad. This is called continuous. So this is possible only with linear regression, whereas categorical, it pinpoint, it will say whether it belongs to class A or class B, or this will be the actual profit. So this is called, this kind of output is given by decision tree, and interpretability high, and it is moderate, because this is actually computation oriented. So what result it produces, it will be more accurate when compared to decision trees, and handles non-linearity. Obviously, linear regression does not deal with variables which don't have relation between them at all, whereas decision tree can handle those data. And overfitting problem will be less in linear regression, whereas it is more with decision trees. So application of linear regression, price prediction, disease classification with decision trees. And some of the tools to implement machine learning algorithms: Python, scikit-learning, Weka, Orange, and code snippets are there. So we can easily use those tools just by giving the optimal data set to train the model. If we do that, definitely we will build an optimal regression model or whatever machine learning model. So we must be very familiar with statistics, probability, linear algebra, and the data structures. In Python, we have a lot of data structures, lists, dictionaries, frames. So we must be familiar, because data sets are represented using those data structures. And whenever we want to train the models with train the models with data sets, we have to identify proper data structure and efficient data structure. So that is why we must be familiar with data structures, OOPS, parallel programming. So image processing and all, even a small picture contains large amount of data. So that is why we go for graphical processing systems nowadays, wherein multiple processing, parallel processing units are there. So we must be familiar with all these things: SQL, NoSQL, regression models, classification, clustering. So these are all the things with which we must be familiar with in order to develop a machine learning model. And few other machine learning tools: sklearn, PyTorch, TensorFlow, Anaconda. So these are all the libraries rich with machine learning algorithms. And that's all. Thank you so much for your patient listening. If you have anything to be asked.
Participants, any queries?
No, mom, it was a nice session. Thank you so much, mom.
Yes, welcome.
Thank you very much, ma'am. Session is very informative, ma'am, and we have learned about these two algorithms in detail, and we are ready to implement in any such area. Ma'am.
Thank you, Uma.
Thank you.
Any
Thank
other
you very much,
feedbacks or questions? No?
Participants, you can unmute your audio and you can give your feedback. They're giving the feedback in the chat window.
Okay.
Okay, thank you very much, ma'am.
The voice is
I
not.
would like to invite Sivashankari.
Yes.
I would like to invite Sivashankari madam to deliver the vote of thanks. Sivashankari madam.
Okay. Okay, ma'am. It's my privilege to propose the vote of thanks on this wonderful occasion of the AICTE ATAL sponsored faculty development program on data-driven model, empowering academician for the data science era. I extend my heartfelt gratitude our management for their constant support and to our respected resource person, Dr. S. Vimala, Professor and Head Department of Computer Science, for her insightful session on machine learning fundamentals, supervised linear regression, and decision tree. Ma'am, your clear explanation and practical approach have greatly deepened our understanding of these core machine learning concepts. Thank you, ma'am.
Thank you. Welcome, ma'am.
Thank you very much, ma'am.
Yes,
Yes, ma'am.
so I once again thank the management and the coordinator. My special thanks to Dr. Uma for inviting me to be the resource person for this FDP. Thank you so much, Uma.
Thank you very much, ma'am. Thank you, ma'am.
Shall I leave now?
Yes, ma'am. Yes, ma'am.
Yes. Thank you.
Thank you, ma'am. Yes, ma'am. Participants in the next session is going to start now, and the session will be handled by Dr. Muthuselvi Madam, Professor, Department of Information Technology, Kamaraj College of Engineering and Technology. Joined here, you can give the guest intro. Sivashankari Madam.
Ma'am,
you can give the guest intro.
Okay, ma'am. A very good evening to everyone. It's my great pleasure to welcome you all to the 5th day of the AICTE ATAL sponsored 6 days online faculty development program on data-driven model, empowering academician for the data science era, organized by the Department of Computer Application, Nadar Saswati College of Arts and Science, Autonomous Theni. It is indeed an honor to welcome today resource person Dr. R. Muthuselvi, Professor, Department of Information Technology, Kamaraj College of Engineering and Technology, Virudhunagar. She holds PhD Information and Communication Engineering from Anna University and has over 32 years of teaching experience. Her research interests include high performance computing and the Internet of Things. She has guided several PhD scholars, published more than 30 research papers, organized many academic events, and received awards such as Best Project Supervisor and Active Researcher Award. She is a life member of ISTE and IE and continues to inspire students and faculty through her dedication to teaching and research, who will be enlightening us on the topic machine learning algorithm. I extend my warm welcome to our respected Secretary, Principal, Head of the Department, faculty members, and all participants from various institutions joining us today, wishing today's session a grand success. The session is yours, ma'am. Welcome, ma'am.
Welcome you, ma'am. You can unmute your audio, ma'am.
Very happy good evening to all. First of all, I would like to thank ACT Training and Learning Academy, ATAL, for supporting the academicians and research scholars to connect through program like this. And I would like to thank management, principal, HOD Dr. Uma, Department of Computer Applications of Theni Melapattai, Nadargal Uravin Murai, Nadar Saraswati College of Arts and Science, for providing me this wonderful opportunity. I'm very happy to present my slides here. So are you able to see the screen? Is it visible?
Yes, ma'am, it is visible.
Yes, ma'am. Okay. I hope I can proceed. So actually the topic allocated to me, that is machine learning algorithms, KNN, clustering model, evaluation and tuning. So the agenda actually, first I would like to introduce machine learning, not to the depth, but at least 1 or 2 lines I would like to say. Then we are going to discuss K nearest neighbors, KNN. K means clustering, hierarchical clustering, evaluation metrics that are used in these algorithms, then how to tune, that is hyperparameter tuning. So all this we are going to discuss. That's what I have in the agenda. So let us start with the introduction of machine learning. Actually, machine learning, all we know, it plays a major role in the modern applications. So the systems actually now, they are able to learn from the data and they are making the decisions which are intelligent. So here, explicitly, there is no need for a vast programming. So there is no need for writing programming for each and every scenario. So that is the beauty of the machine learning. And in many applications like disease prediction, it may be in the healthcare area or credit card fraud detection. Recently, we are hearing a lot of news like that. So for fighting the frauds, actually, machine learning it is playing a major role. Then recommendation systems also, it is having its own significance. Then for autonomous driving and route optimization, again, machine learning is having its own significance. Then one more important application that is in education. So here for personalized learning and for predicting the students' analytics, that is predictive student analytics, actually we can use machine learning. So here two important ideas we got to know. One is supervised learning, another one unsupervised learning. So if we look at this supervised learning, actually the machine learning algorithm or the system, it learns using input-output pairs. Actually here we call the output pair as label data. So it is like a teacher providing the correct answers. So we would like to learn from a teacher. He is providing the correct answer. So some examples are email spam detection. That is, we can say either the email is spam or not spam. Then another example, it is medical image classification, where we can say whether the result is benign or malignant cells. So for that, we need the classification, and for that again, machine learning plays a important role. Then house price prediction, that is another example. So here, the goal is to learn a mapping from the inputs to outputs. So that is the main goal. Some example algorithms are linear regression, decision trees, KNN, SVM. All these are some key algorithms used. Another approach is unsupervised learning. So here, the system learns without labeled data. Simply, it identifies a hidden structure or patterns in the data. So customer segmentation, that is a good example for this one. So in a shop or in a mall, one particular group of people, they purchase a group of items. So like that, the customers can be segmented. So for that segmentation, unsupervised learning is very much useful. Another one is anomaly detection, that is the fraud patterns. So that can be easily detected by unsupervised learning. So here the goal is just to explore and organize data meaningfully. So here we don't have any predefined output, but without that, we have to explore and organize the data. And machine learning actually, it plays a important role there. So here one example algorithm is K-means, which we are going to discuss today. So in simple, we can say in supervised learning, we have the input data, which is given as input to a model, and I will be getting some output which will be combined with the labels. Whereas in the unsupervised learning, some input data we are going to give to the model, and you will be getting the output. So here you don't have any labels like that. So these are some key differences between supervised learning and unsupervised learning. So in the aspect of data, in supervised learning, it is labeled, whereas in the other case, it is unlabeled. So some examples for supervised learning, classification and regression, whereas for unsupervised learning, we have the algorithms like clustering, dimensionality reduction, like that. So if we look at the output, in supervised learning, we'll be having known labels, Whereas in the case of unsupervised learning, some hidden groups or relationships will be there as outputs. So let us delve into this KNN. The first question, what is KNN? So actually, it is instance-based supervised learning. So here we are going to use one parameter called K. So using that, we'll be having this KNN. So here it is going to predict output by using the label neighbors, and we can say it is non-parametric. So the definition for this one, actually we can say like this. It is a machine learning algorithm which classifies a new data point by finding its k nearest neighbors in the training data and assigning it the most frequent class among them. So that is the definition given to the algorithm. So now, what is k? That is the next question. K is we are using. So it is just a number. Actually, this particular number, it tells the algorithm how many nearby points actually it is going to use for making a decision. So here we can say it is a nearby points, or actually we are using the term neighbors. So for making a decision, how many nearby points this particular algorithm will be using. So that is what K. So let us take one simple example. So I would like to decide which fruit it is. That is, I am given one fruit. So I have to decide which fruit it is based on the shape and size. I have to tell. So what should be done? Actually, this given fruit, it should be compared with the already known fruits. So here, the system or the algorithm, if it is taking k value as 3, then what is the meaning? It looks at the 3 closest fruits to the new one. So I have 2 different groups. So the group in these 2 groups are it is going to take the nearest fruits which are very close to the particular fruit. So here, if 2 of those 3 fruits are apples and 1 is a banana, then simply the algorithm will declare the new one is an apple. So that's how actually the k value is used in the algorithm. Let us see the procedure for KNN. The first step, what I have to do, I have to choose the number of neighbors. So I would like to focus on this. Actually, it is an integer value. So the number of neighbors to be considered for selection. And the k value, it is actually very, very crucial, because if it is very low or if it is very high, then we won't be getting a good result. So we would like to focus on the value of k. That is very important. Then the second step, we have to calculate the distances. So here we are going to have a new data point, and it should be that is the distance between the new data point and the points which are closer to that distance. First it should be calculated. Actually, the other points, they are available in the training data set. So from the training data set, I will calculate the distance. Of course, we have some methods for calculating the distance. 2 important methods are Euclidean, the other one Manhattan. The third step, actually, we have to find the k nearest neighbors. So here, whatever the data points actually we are going to have, they will be sorted by the distance to the new point. So of course, we are going to focus on more than one data point, which is closer to the new data point. Now, sorting will be done on the data points. So now, the k points with the smallest distance, that will be selected. So that's why we are going to find the k nearest neighbors. Then the next one, to make a prediction. So the prediction may be for classification or it may be for regression. Let us focus on classification. So here, actually, I'm going to find out the number of neighbors. Actually, that is to be counted from each category. Then the new point actually assigned to the class, which is the most frequent among the k neighbors. This particular method actually, it is known as a majority vote. Actually, we call that as majority vote. Then for regression, how the prediction is made? Actually here, the average of the values of the k nearest neighbors are calculated, and this particular average, actually, it is the predicted value for the new data point. So these are the steps actually we are having in KNN algorithm. So with the pictorial representation, we'll be able to understand it easily. See here, two different classes actually we have. So target point, actually there is a new data point which is shown in violet color. So we have to find that. So now in the second picture actually, we can see a group of points now which are closer to the new point. That is, we have to identify, that is the algorithm identifies that they will be grouped. Then among them, that is the new data point, for that the prediction will be given. So the applications actually where we are using KNN, that is, I have given two important examples. One is query point classification. So here actually Euclidean distance, that is used to calculate the distance between the points. Another one showing majority voting. And another question arises. So how to select k? Of course, I told you it should be a reasonable value. We should not go for a higher value, or we should not go for a lower value. So some statistical methods are available to select k. One is cross validation. Actually, it is a very good way. This cross validation for selecting k. What actually it is doing? Just it divides the data set into k different parts. Then some parts are trained, whereas the remaining parts will be used for testing. Then the k value, which is giving the highest average accuracy, that will be selected for using in KNN algorithm. Another method is elbow method. So here what we are going to have, simply graph will be drawn. So the graph is showing the error rate or accuracy. So if I go for different k values, what will be the error rate or accuracy? Any parameter I can use. So just that will be plotted in a graph. Then we can see if k increases, then the error actually is going to drop at one particular point actually. So after a certain point, that decrement that will be stopped. So where the curve changes its direction, actually it looks like an elbow, and usually that is the best choice for selecting k. So that is the elbow method for selecting k. And regarding the distance calculation, that is one important step, how we calculate the distance between the new data point and other points. So here Euclidean, Manhattan, Minkowski distance. So three methods are available. So if we take a Euclidean distance, actually it is used to identify nearest neighbor. Actually it is defined as a straight line distance between two points. See from the picture we can see two different points. A with coordinates x1, y1, whereas B is of coordinates x2, y2. So now we have to find out the distance between these two. So I'm using the formula D is equal to square root of x2 minus x1 square minus square root of y2 minus y1. So this is called Euclidean distance. So another one, it is Manhattan distance. From the picture you can see, suppose I'd like to move from A to B. So simply I'll be moving in horizontal direction, and for quite some time I'll be moving in the vertical direction, like that. Just we are moving through the different streets, city streets. So similar to that one, the distance actually is calculated. So here we call that as taxi cab distance, because a taxi actually that can only travel like this along the streets, it can travel, so the name is given like that. If we look at the value for D is equal to the absolute difference between x2 and x1, that is added with the absolute difference between y2 and y1. And the third one, Minkowski distance. So here simply look at the picture. So here actually it includes both Euclidean and Manhattan distance. Both are included, and special formula is used for this one, where I'll be having, see here, the collection of sum of values between x and y, between a and b. So the difference between xi and yi to the power p to the power of 1 by p. So that is the formula given here. So here for p, either we can have the value as 0, or we can go for 1. That based on Euclidean distance or Manhattan distance. That's why it includes both Euclidean and Manhattan distance. And if we look at the applications, so in a recommender system, actually, whether it may be for a movie or some products, we can use KNN. Then we can use KNN for identifying the mails, whether they are spam or not. Suppose a new email that will be sent to us, so that will be compared with the previous one, and it will be able to say whether it is spam or not spam. Similarly, customer segmentation. So grouping the customers. So for that, we can use KNN. For speech recognition also, we can use KNN. And actually, I have implemented for that is implemented KNN for one particular application, that is there I'll be able to show the adjustment of K value. So actually I used Google Colab. So here, if we adjust the value of K, what will happen? What happens to the accuracy and all? So here the objective mainly I'm going to understand KNN algorithm that scikit-learn that actually that is used. So here iris dataset that is taken, 150 samples are taken, and 3 species are considered here. So the purpose of this one, it is classify the flowers using KNN. So here the libraries, I have used different libraries. Then data, that is iris data set, which is selecting two only. For simplicity, I have selected only 2 features, but we can go for more than one. So KNN will be trained with the chosen K. So my work actually that implemented work, it shows different values from 5 to 15 different values I can select, and it will predict. Then the result will be shown in a confusion matrix. So here I'm able to get accuracy 95 to 100 percentage, and future work actually we can extend it, especially for finding the students' performance. Actually, we can use this particular algorithm. So this is what the result actually I have got. I will try to show you that implementation. I think it is that particular screen. I am not able to share it. Sorry for that. Actually, I have run that in Google Colab, and the result actually. So 3 different species. So whatever the data set I have given, using the confusion matrix, actually, I am able to get the result. So this is what the result I have obtained. Around 120 samples actually I have taken. And if you look at the advantages of KNN, actually it is very simple to use. So here there is no training step. There is no need for training. And parameters, it is very limited. Actually, only this K value, actually we have to focus on. And the other one, the distance method. Actually, which method we are going to use. Only these two we have to concentrate. And versatile, that is, it is able to give good result for both classification and regression problems. So these are the advantages. Anyhow, we have some disadvantages also. But if we go for large data, then automatically it slows down KNN. And then if we go with many features, then we'll not be able to get good result with KNN. And it can overfit also. That is also another difficulty we are facing with KNN. So practically for larger data, then we are not able to use KNN. So the next one actually it is K-means. It is an unsupervised clustering algorithm. So here actually what it is going to do, simply it groups the data into K different clusters. So it's purely based on the inheritance similarity. So based on the similarity, we will have K clusters, and from that it is going to give the prediction. So especially for segmentation, anomaly detection, we are able to use K-means. So here simply it categorizes the items into K groups or clusters. So here the similarity, actually the clusters which are similar. So based on that only the categorization will be done. And for calculating the similarity, again Euclidean distance that will be used. And we know the formula for finding the distance using Euclidean. And here this is how the K-means clustering can be implemented. That is, these are the steps. So first step is to initialize. So here the random selection of K cluster centroids. So first we have to select that K value. Then the second step, it is assignment. So here the data point actually that is assigned to the nearest centroid that is forming the cluster. The third step, it is update the step. So after this assignment, actually the centroid of each cluster, it should be recalculated. So for recalculation again, the average value that will be used, and we have to repeat this procedure until there is no much change in the centroid. So up to that, we have to repeat the procedure. Here also, the important thing, that is we have to select K. So for that, we can go for elbow method. So which I told you that using a graph, that is we will have different K values and they will be plotted, and from that we can select the K value. Another one, Sillout score, that is another method which is used for K. So here, of course, we have specific formula, whether we are using elbow method or this Sillout score. For finding the distance, we have the formula there. Then for centroid updation, again, we have a particular formula. Using that, we can update the centroid. So till there is no much change in the centroid value, we can go for repetition. So an educational data mining approach, for that actually, again, I have implemented using this K-means. So this is what the Python code actually I have used. So here I'm using matplotlib for plotting. Then here actually I tried with very smaller set of data. That is, I have taken attendance and the quiz score. So 7 data only I have taken. So I applied k-means. So here the number of clusters actually I have taken as 3. Then the random state actually I have taken randomly as 42. Then I have plotted the values. So the result is given like this. So the attendance and the quiz score. So here the students' performance, that is shown here. So by using this one, we can predict what is the relation between the attendance and the score by the student. So we can go for the real-time data also. So here simply I have taken randomly the data, but we can go for the real-time data. So in that case, the data may be of a larger set. I mean, in a class, we may have some 60, 70 students like that. So in that case, that can be stored in a Excel sheet and a CSV file can be used. Since here I have taken a simple set, I have shown it, I have used it directly. And if we look at the pros and cons of k-means, see again, it is simple, scalable. That is, even the data may be that what I have taken only 7, but for 70, 100 like that. So more number of data we can go for. The scalability is very good as far as k-means is considered. Interpretable. So that is also very important thing about the k-means algorithm. And if we look at the difficulties we face with k-means, again, we have to select k value correctly. So that is very important. And it is very sensitive to outliers. And it always assumes spherical clusters. But practically, sometimes we may not have the spherical clusters. At that time, we will face difficulties with k-means. So here also it is very important to choose the right number of clusters, k. So here we have to decide how many clusters actually we are going to use for our application. And the next one actually sensitive to initial centroids. So that is also an important challenge that is we are going to face with k-means clustering. As I told you, sometimes non-spherical clusters. So that actually we assume as a developer or programmer, we assume simply we are having spherical and all the clusters are equally sized. But if it is non-spherical, then when we are exactly using an application where the clusters, they may not be spherical. So some non-spherical clusters may also be used. In that case, the result actually that may not be good. That is a correct result. The accuracy may not be good. So that is another challenge we will have with k-means. Then if we look at the outliers, k-means actually it is sensitive to outliers. So what happens because of this one? The centroid can be distorted so that the clusters, they will also be distorted. So it may lead to have some non-spherical clusters. So that is another difficulty we will have with k-means clustering. Then the next one, it is hierarchical clustering. So here agglomerative or divisive, that is merge or divisive. Which one we are going to have? So here there is no need for the value k initially. So actually it is an algorithm which is using the idea unsupervised learning. So here actually it is going to group similar data points into clusters. So here it is using the hierarchy for forming the clusters. So hierarchy in the sense we all know tree data structure. So there we have the hierarchy. Similar to that, here also it is going to group the points into a cluster by using the hierarchy among them. And initially, actually, we are not going to use any k value. So there is no need for the number of clusters. So whereas in the case of k means, actually that is specified as one of the challenges. There the k value is very important, which is not at all required in hierarchical clustering. So one simple example, let us assume we have the different fruits like this with some weight: apple 100 grams, banana 120 grams, cherry 50 grams, and a grape 30 grams. So now each and every one is belonging to a particular group. So now what we are going to say, each and every one, actually each fruit, actually it is going to be a cluster. So now what that is the algorithm. What it is going to do, it will merge the closest item. So here we can say cherry and a grape. So they will be grouped. And apple and banana, they will be put into another group. Okay. Then these two clusters. Now I have two clusters. Again, these two clusters will be merged into one. Finally, I'll be having all the fruits merged into a larger group. So this is what actually hierarchical clustering. It actually progressively combines the most similar data points. So based on the similarity, here the clusters are formed. Again, the clusters are again combined into a single large set, and we are going to, that is the algorithm, it is going to find out the data. And actually in hierarchical clustering, we have two types: agglomerative clustering, another one divisive clustering. Let us focus on agglomerative process. So here we have to start with the single point. Then the closest clusters, they have to be merged. So we have to repeat this particular step till all the clusters are merged. Then we are going to visualize it with dendrogram. Actually, with the hierarchical clustering also, we have some pros and cons. So here exactly there is no need for focusing on K. And dendrogram, actually it is intuitive. And if you look at the difficulty, computationally expensive, that is very important, because we are forming clusters, and again they will be merged. So till we have one large set, the merging or combining the clusters, that leads to more computations. So that is the difficulty. Automatically, if more computations are there, then the time taken, so that will also be high. So that's why it is mentioned as expensive. So that is one important difficulty we have. And another important thing, so many algorithms we have. For example, that is this KNNK means everything we have seen, SVM, all these are available. But what are the metrics? Because without the parameters, how our system, whatever the system we are developing, that is performing, that is very important. So we have to focus on the evaluation metrics, that is important. So here, usually we prefer accuracy, precision, recall, F1 score. So these are the important parameters we are using. If we look at accuracy, this TP plus TN by TP plus TN plus FP plus FN. I hope all you know TP is true positive, TN is true negative, and FP false positive and false negative. So these are the values actually we are going to find we are going to use for finding the accuracy. Actually, accuracy, it measures the overall correctness of the model. So how much accuracy actually we are going to have. So for comparison, comparing different algorithms, we'll be using this accuracy and as one parameter. The other one, precision. The formula for this one is TP by TP plus FP. So simply it measures the proportion of the correctly predicted positive instances. So our focus is on positive instances. So out of all instances predicted as a positive, how many we have, how many correct predictions we have. So that will be giving the precision. That is also very important. Another one, recall. So here simply it measures the proportion of correctly predicted positive instances out of all actual positive instances. So here we will include both true positives and false positives. Both will be included for finding this recall. Another important one, F1 score, and this is the formula 2 into precision into recall divided by precision plus recall. So this is the formula for F1 score. Actually, what is the significance of F1 score? Simply, it is able to calculate the harmonic mean of precision and recall, so that we'll be able to get a single score which balances both metrics. So both we are going to have, that is both precision and recall. To have a balanced value for this, we can go for F1 score. So if we use Google Colab, so automatically we'll be able to get the accuracy value and everything. So if we are going for more than one algorithm, we can compare the values for F1 score, precision. We can make a comparison, and even we can plot that, and we can say which one is better. For that purpose, we can use that. And if we use clustering, so there we have the Szilard score, Davis Bolden index, all these are available. So these parameters actually we can use. Of course, they are also having their that is the formulas are available in the net. So actually, I'm not able to. I have some difficulty in typing the equations here, so that's why I have left them. But these are available in the net. And of course, another important thing is tuning. That is very, very important. So simply I know the algorithm, I know the steps, I'm able to implement, I am able to run the program. That is one thing. But selecting the values, it is very, very important. So simply what we can do, if we use KNN, we have to choose K. So different methods, actually we have some statistical methods we have for selecting K. So if we are doing some research or some project work students are doing, what we can direct, just we can choose different values for K. So one algorithm we can develop, and we can try with more different values for K. Even we can make the comparison. So that is also a part of our study of that is either in the research work or the students are doing a project. We can show that. Another one, distance. So 3 different methods for calculating the distance we have seen. So that also we can try, even in a single project or single work. Even if you are preparing for an international conference, what you can go for different methods for calculating the distance. So even that can be shown as a result, and we can make some inference like this one is better. And even for one particular K, 3 different calculating methods for distance. Another K value, 3 different methods. Like that, we can do our research Even we can direct students who are doing project, we can make them to do the work. And that is each and every part that is that can be presented in an international conference, and all these combined and put into a single paper, so that that will be published, that can be published in a journal. So that's how we can go for the tuning. So that's what the meaning of tuning. And if we look at that k-means, so here again, selection of k is very important, and the initialization, that is also very important in k-means. So here also you can go for different clusters, and you can make an inference. You can make a comparison and make some inference. Like this one is better for this particular k, the result is not good. Like that, we can give some inference. So if we go for hierarchical, so here linkage method, different linkage methods or cut level, actually that is also available there. So by having different values, we can tune the algorithm. So for getting a good result, actually the tuning, that is very much important. So if you have any question, or discussion.
Participants, any queries?
So I request Nadipriya to take one screenshot. So I have switched on my video.
Yes, ma'am. Yes, ma'am. Now I'm taking, ma'am.
I request Dr. Uma to join the session in video.
Video,
Is it
ma'am.
possible?
Yes, ma'am.
Thank you so much, Dr. Uma.
Yes, ma'am. Thank you,
So
ma'am.
I'm happy to share that she was my student and providing me this opportunity. Thank you so much. And actually, currently I'm recognized supervisor in Anna University.
Oh, super,
So
ma'am.
already I have been guiding 7 scholars. So one more slot is free for me. So if anybody is interested, you can join. So the details you can get it from Ms. Nadi Priya. And another one, apart from that, not only for that, if you have any other queries or anything, my mail ID, it is mselvi. Actually, I have that in the PPT also, or otherwise that can be shared in the chat. You can send the queries through the mail also. Already it's very late. So my mail ID. Any queries you have, please send. Surely I will answer you. Thank you so much for the opportunity. Thank you, Dr. Uma.
Thank you, ma'am. Thank you very much for your wonderful session, ma'am. It is highly informative. And today, both the sessions are very high informative sessions regarding the machine learning, ma'am. Thank you very much, ma'am.
Thank you. I thank all the participants for your patience. Even after 7:30, you are listening to that. Thank you so much.
Thank you so much, ma'am, for sharing your knowledge.
Thank you, ma'am. I request Shivashankari, ma'am, to deliver the vote of thanks. Sivashankari, madam. Okay. I feel immense pleasure in delivering the vote of thanks for today's session. Sorry. Especially first and foremost, I thank Dr. Vimala ma'am, Professor and Head Department of Computer Science, Mother Teresa Women's University, Kodaikanal, and followed that in the second session, Dr. Muthuselvi ma'am, Professor, Department of Information Technology, Kamaraj College of Engineering and Technology, Virudhunagar. Both the sessions are very useful, ma'am. Really thank you for delivering useful information to the participants, and special thanks to all the participants, those who joined today's session. And the feedback link is shared in the chat box. You can make use of it. So still it is not shared. It will be shared now. You please give your attendance as well as the feedback in that link. Thank you very much, participants. And the tomorrow session will be start by 6 o'clock. Thank you very much. The feedback feedback link is shared in the chat box, ma'am. Sir, you can make use of it. Thank you very much.
Okay. Thank you,
Thank
ma'am.
you. Thank you.